My name is Fanny. I'm working at the Constellium Research Center in Vorep and mainly on automotive alloy developments with a recent focus on both recycling and formability. Recycling is key for aluminium circularity because aluminium can be recycled without losing its properties. And if we consider the recycling of aluminium, we only need 5% of the energy required to fabricate primary aluminium. This gap is huge, and it's the reason why recycling is really the way we have to follow to decarbonize our products. Aluminium is infinitely recyclable, but to make this happen, we need the alloys to be segregated by alloy families. If they are mixed together, they won't reach the expected properties, and they will usually end up their life into the secondary casting alloys. For example, if you consider vehicles, and in the vehicle you have, for example, the doors, the roof, each of these parts, the closures, they are made in two parts, really. You have like the inner part and the outer part. And unfortunately, these two parts, they are made of two different alloys. So we have the outer part is made of the 6,000 alloys, whereas the inner part is mainly made of 5,000 alloys. And the difference between these two alloys is the chemical composition. The 5,000 is aluminium with a lot of magnesium, up to 5% And if you consider the 6,000, it's a mixture of aluminium with magnesium and silicon, and the content of magnesium is much lower than in the 5,000. In some stamping lines, it's not possible to sort the scrap by alloy families. It's more related to the way the line is designed, and at the end, when you stamp a part, you will have a lot of stamping scrap, let's say, that come from the cutting and stamping operation. And if these scrap are mixed together, the 5 and the 6,000, we won't be able to recycle them back into the initial alloy. That's why we need to work to separate this alloy. The most promising way to separate the alloy by alloy families is to use LIBS for Laser-Induced Breakdown Spectroscopy. It's not a new technique. It exists in the lab since several years, but now it's becoming industrial. We have a first, let's say, industrial experience on LIBS sorting of stamping scrap. We have been working with a supplier of Constellium, a scrap dealer that has bought an industrial LIBS line, and in collaboration with a premium German OEM, we have put in place, I would say, the world's first sorting sequence in order to separate the 5,000 and the 6,000 coming from their production line. And it's quite industrial now. The line is running at 5 tons per hour. And in 2023, Nebrisac plant has used more than 3,000 tons of this scrap coming from the sorting process in its melting furnaces to redo automotive products. Let's explain a little bit how LIBS is working. In LIBS you have a laser, and the laser is going to hit the metal piece, and when it hits the surface of the metal piece, it's going to create a plasma, and within this plasma you have excited atoms and ions, and when the plasma cools down there is light emission, and then we analyze this light emission, the different spectra you got, the different rays, and from that you can recover really the exact chemical composition. Now, if my laser is hitting a 5,000 piece, I will have a really strong signal from the magnesium that I won't have in a 6,000 piece, for example. How is an industrial LIBS line working? You have like really a conveyor, where it's a high-speed conveyor in which the pieces are located. Usually you have a first laser that is going to locate the pieces, to measure the 2D surface of each piece, and then there will be a second row of lasers, and the laser is going to go to the piece to measure the chemical composition, and depending on the results, it will last few milliseconds, and depending on the results, the piece will either be ejected by air jets, or it will directly drop down, and at the end you will have two batches Normally the 5,000 on one side and the 6,000 on the other side. What we think at Constellium is that this LIBS technology that we use for the moment for stamping scrap will be really important in the future when we will deal to end-of-life vehicles, and if we want to recover the aluminium that is included in these vehicles, first we will need to separate from the other materials, from the glass, from the plastic, from the steels, but we will still be with the mixtures of aluminium alloy families, and the LIBS will be very useful to separate once again the 5,000 and the 6,000. And we have been doing preliminary trials showing that it's really working well also on end-of-life parts that are painted.